So with related rates, here are your steps, and hopefully you have those written down. All right, so we are going to turn our books to page 149. And what we're going to do is go through examples out of the book. And then your homework will be to finish the ones that we don't get done in class. Every day. Every day, that scares me. 149, number 13. What? That is a book. Will you share with Christy for now? Shelby?
Where did that page come from? Me.
It's yours.
There's one in here.
You can, yeah. I don't know whose book it is or if it is somebody's. All right, so number 13, the first step is, well, of course, to read it, but to say what we know out of that number 13 problem. So, find the rate of change of the distance between the origin and a moving point on the graph of y equals x squared plus 1 if dx dt is 2 centimeters per second. So what do they give us in this problem? Okay, they give us a derivative and an equation. What equation do they give us? And what's the derivative that they give us? Okay, so dx dt is 2. What does that mean? Derivative of what? Derivative of x with respect to t. So if you want to write it with our other notation, you're going to put x prime there. So whatever is on top is your prime one. So that is what we know. What do we want to know? Yes, rate of change of what? Okay, so they want to know the rate of change out of distance, correct? What do they mean when they say rate of change? The slope. So they want the slope of our distance. So they want the derivative of our distance. That's what we're going to be trying to find. Well, what is the distance between? What are they asking you to find the distance between? Origin. Okay, and where's the origin? And any point on our graph, correct? So if our x that is x, what is our y value? Careful, it is y, but we want to use a different, instead of incorporating another letter in here, how can we represent y in terms of x? X squared plus 1. So this came from our given equation. Questions on that? How do you find distance between 2 points? You subtract them. Okay, so we're going to subtract our values. So we're going to go x minus 0. What do you do once you subtract them? You do something else. What's our distance formula? Not divided by 2. That's midpoint. You square it. Add the distance of the other point. So you find the difference in your x's, the difference in your y's. You square them. And then what do you do with that? Unsquare it. It is like the Pythagorean theorem. Yes. Questions so far?
Why do they have you square and unsquare?
Because this part squared and then unsquared is not going to just be that. Because there's plus in here. So that changes things. So they want us to find the derivative of our distance. So they want us to find the derivative of this equation. So we got some work to do here. Let's simplify inside our parentheses, or underneath our square root. What does underneath our square root equal? X squared plus x to the fourth plus 2x squared plus 1. Do we agree? Questions? So we need to find the derivative of that. Can we simplify that even more? So we could write this as d equals x to the fourth plus 3x squared plus 1 quantity square root. So to find the derivative, what do we get to do? Can't square root.
You have to do chain rule.
You have to do chain rule. So we got u, d equals u to the half. U is x to the fourth plus 3x squared plus 1. So what's the derivative of d? Do we agree with Frankie? Okay. What's the derivative of u? Do we agree with Allison? All right. I need a new slide, huh? So, all right. So, if you were here, you had u to the 1/2 u to the negative half and 4x cubed plus 6x. Questions on that? All right, so, why am I going back? So 1/2 u to the negative half, and what was the other one?
4x cubed plus 6x.
Okay, so we're going to put in u. So we have 1/2. Thank you. Beautiful. Times that, correct? Can I put that on top? Okay. Well, hopefully that won't confuse you if I put it on top. All right. So, our derivative of d equals this, correct? When we did this, we did the derivative of x on the right side. I get my left and rights confused, sorry. So, we did the derivative of x on the right side. Before, we never put x prime, correct? Since it is a word problem, we now have to put x prime or whatever letter on all of them. So this one is times x prime. If it is a word problem, you now have to put times the derivative that you took the derivative of that side. Before, when we did the derivative of y, we would put times y prime. Now we have to do it for both because it is a word problem and it's not necessarily going to be always for x, where all of our other problems were always for x. Okay? So in our given piece of information, it says find the rate of change between the distance between the origin and a moving point when dx dt is 2. So you plug in 2. Questions on that? you plug it in for x prime. Yes.
Also?
Only.
Oh.
Oh.
What is that noise?
What?
So if you wanted to, you could take the top times 2, or could we cross out that 2 on the bottom? Questions on that?
Then it's 8x cubed plus 12x over whatever.
2 times, yes. Or if you wanted, you could cross those off if you wanted to reduce it. So you could have 8x cubed plus 12x over all of that. Yes. Or if you